So I've had something weird come up with this electrical system, and it's called a thermal joint. Check this out. So in this image, you can see the thermal joint is from Honda, and it goes to a certain part of the system. On the wiring diagram, there's 4 of them total, and I have one coming from the throttle unit, which is in the front of the car. Then I have one coming from the ECM, which is in the front of the car. And then I have all these other ones which are on the transmission, which would be in the wiring harness that I'm making right now. So what I did is I put a thermal joint, because these 2 are tied together right here. Put a thermal joint here going into the connector that's going to connect to these here. And I'm going to run the ground. The ground that it's actually ran to is on the engine itself. The G101 ran on the engine itself. So I'm going to put one from these in between here and the ground also. And that allows, basically there's 2 of them in here now instead of 1. And it gives me the thermal protection I need. And here's how I did it. I made these right here. This is basically a crimp joint connector that allows to expand and contract and keep its connection. And this will be wrapped in heat shrink. This is what the crimp connectors look like. They're both the female side. And I took a pair of pliers and just crimped one side down and made it to where it goes in there very tight. The reason why these are done that way is because of what they call heat soak. From what I can find, from the information I'm finding out, it's heat soak. The engine bay in a TSX is notorious for being very, very hot. Well, now I'm putting the engine in the middle of this car with all that heat. But I did some things. I mitigated the heat by making a custom exhaust with a powder coating on it, or a ceramic coating on it, that helps push some of the heat out. But I also made the radiator system on here where it has a scoop under the bottom, pulls the air from the top, comes in, and then goes out the back like this. And creating that, and then with combination with these vents right here, it should create a vacuum under the car and literally suck the heat out from under the car with it. So as you're going down the road, this low pressure area that's going to create with the air moving out really fast should create a low pressure area in here. As you're moving down the road and air is coming from the front of the car, which should actually pull the heat out from under the car, which in turn will pull the engine, all the heat out from in the engine bay. Now, the other thing I have is these vents. So when you're sitting at a stoplight, the heat should escape basically through these vents. But it also has the fans running pretty much all the time, still pulling air and creating a vacuum back here. It should, so to speak. But if it doesn't, I still have these in the system. And if it gets too hot, it's not going to create heat soak. Heat soak is caused from the heat going into the wires basically and changing the resistance of the wires in the system and creating problems with voltages and things like that. So it's going to be covered in heat shrink, and I've used high temperature wires in the system that I've done, but that doesn't mean that the wires that are on the engine are high temperature wires. In fact, they're not, and I know it because when I use a lighter on them to do the heat shrink, the wires start to burn much faster than the heat shrink is already done. So I have to be really careful when I'm doing heat shrink. But the wires that I've basically connected into the system, you can put a lighter on them and they won't burn at all. So I've still got to put these in here for safety issues, for just to be safe about it. Not really safety. It's more along the lines of just making sure the computer reads its readings properly and things like that actually keep working properly as it does get heat in here. So hopefully it keeps the issue from happening, and everything will work out just fine. That's your lesson for today. Have a good one.